Hello, welcome to Unit 6. This unit will focus on triangle trigonometry and refreshing your knowledge of trigonometric functions such as sine, cosine, and tangent, and how we use them in right triangle problems in order to help us solve and find given information. This video is going to specifically focus on the Pythagorean theorem. So very light work, should be mostly review, but we need a solid foundation. Our learning target is to use the Pythagorean theorem to find the missing side measurement of a right triangle, and you'll be successful if 1, you can know the Pythagorean theorem, you can identify the hypotenuse of a right triangle, and you can use the Pythagorean theorem to find a missing side measure of that right triangle, and when necessary, simplify a square root. So let's go ahead and review what a right triangle is. A right triangle is a triangle in which there is a 90-degree angle, and a 90-degree angle can be seen, usually indicated with this symbol here, telling us that these two line segments are perpendicular, and that this angle contains 90 degrees. Now, when you have a 90-degree angle, you will have two acute angles that are less than 90 degrees. And this is because the sum of all of our angles adds up to 180. So if this is 90, then these two must add up to 90. Therefore, they're both going to be less than 90, which makes them what we call acute, because they're so cute, right? We're going to go ahead and also review what a hypotenuse is. A hypotenuse is always the longest side. Here's always the longest side, and it is directly across from your right angle. So here's your 90-degree angle. That's going to be the hypotenuse. The other two sides are what we call legs, and they are what form the 90-degree angle. So if you're ever unsure, your legs form your 90-degree angle. Hypotenuse is the side across, and that is always your longest side. So let's start out very, very simple, and we just want to go ahead and we want to identify the hypotenuse of each right triangle. So pretty straightforward here. Right across from the right triangle is our hypotenuse. So there you go. That's it. Not too bad. Example 2, here's my right angle. So the side across from this is our hypotenuse. Okay? Pretty simple. Please take a second. Go ahead. I want you to find the hypotenuse of these two right triangles. Pause me if you need to. All right. Hopefully you found them. The hypotenuse is going to be this side and this side, directly across from your right angle. Pretty easy stuff, right? Okay, so let's go ahead and let's dig up our knowledge on the Pythagorean theorem. And the Pythagorean theorem is a formula developed and, or I guess made widely popular by the group of the Pythagoreans. And they came up with this, that if you have one side squared plus the other leg squared, that's going to equal the distance across squared. Okay, and so the famous formula is a squared plus b squared equals c squared, and that's going to be your leg squared plus your leg squared. Very important that your legs are your a and b. Doesn't matter if you can switch these. Your addition is commutative. I can interchange these. A and b can be each other, but c must be the hypotenuse. The side that is equal to the sum of the other two must be the hypotenuse. Okay, so very, very important. Hypotenuse must be identified. Okay, so that's the Pythagorean theorem. A squared plus b squared equals c squared. So let's go ahead. Let's look at an application of this. Example, find the missing side of the right triangle in simplest form. Okay, what we're going to go ahead and do first is I'm going to label. I want to label this triangle, and specifically I want to label the hypotenuse. So here is my hypotenuse, that's 6, and if the hypotenuse is 6, then this side is c. Okay, now I'm going to go ahead and I can label this side x, I can label it y, I can label it a, I can label it b. Doesn't matter. I'm just going to give it some variable here. I'll give it x. And then I'm going to go ahead and I'm going to write my formula, the Pythagorean theorem, which is a squared plus b squared equals c squared. If you need to write down the Pythagorean theorem, you can go ahead and do this. And a, let's just call a our x here. B, that's going to be the other leg, which is 3. And then our hypotenuse is our c value, so 6 squared. So we get 6 squared plus 9 is equal to 36. And then we're going to go ahead and solve for x. So I'll subtract 9 on both sides to give us 25. And then we'll go ahead and solve for x by undoing our power of 2 by taking a square root. And we get x equals 5. And maybe you are thinking to yourself, hey, what about the plus and the minus? Where's the negative? Yes, when you're solving, you do have a plus and a minus. However, in this case, we're talking about distance. Distance is always positive, so that's going to be just our positive quantity here. Okay, example 2. Find the missing side of the right triangle in simplest form. Well, again, what you're going to do first is you're going to label. I need to make sure that I know that, hey, this is my hypotenuse, so this is going to be C. It's my missing side. Okay, well, if that's my missing side, then Pythagorean theorem says a squared plus b squared equals c squared. So I can say 3 squared plus 4, that's a 4, squared equals c squared. If you want to call this side x, that's fine. You can do that. We'll go ahead and compute. So 3 squared, well, let's see about the next one. 3 squared is 9, plus 4 squared is 16, equals c squared. So we get 25 is equal to c squared, and we can go ahead and take a square root if my pen will cooperate with me, and so we get c is equal to 5. Again, this is equal to 5. Okay, that is the Pythagorean theorem. Now note the difference between the last two examples is in this case our variable was the hypotenuse, so I placed that by itself on this side. In this case over here, our variable, the side that was missing, was a leg. So I placed that missing variable on this side with the summation of the other side. Very important, the placement there, okay? All right, so we have 4 practice problems here. Let's go ahead, let's focus on these 2. Go ahead, try to solve these 2, and then I'll show you your work, and then we can focus on the other 2. And here's what I want to do first. Before you go ahead and solve these, I would just like you to write a proper formula. A squared plus b squared equals c squared. I want to see if you can write a proper setup for the Pythagorean theorem, because believe it or not, that's what troubles most students. Okay, so go ahead, pause me if you need to, write an equation to represent this situation, and then we'll solve after. Okay, hopefully you went ahead and you identified this missing side as the hypotenuse, and so this is your c value. So this equation set up would be 5 squared plus 12 squared equals c squared. C squared. Did you get it? Hopefully you got it. Okay, good job. All right, next example. Over here in this example, this is a leg. This is a leg. And this is our hypotenuse. So I'll just go ahead, I'll call this missing side x. So our equation setup is going to be 2 squared plus x squared is equal to 4 squared. Did you get it? Hopefully. Okay, now I want you to pause me and I would like you to solve these 2 equations. Go for it. All right, hopefully you went ahead and solved here. Looks like we have 25 plus 144 is equal to c squared. So we get 169 is equal to c squared. Taking a square root, you get c is equal to 13. So this side is going to be 13. All right, example 2 over here. This gives us 4 plus x squared is equal to 16. We'll go ahead and subtract 4 on each side. And we get x squared is equal to 12. And when we go ahead and solve here, we get x is equal to the square root of 12, which, can you simplify that? Go ahead, please simplify that if you can. Remember, you want to look for a perfect square that's a factor of 12. So in this case, we have square root of 4, square root of 3, which gives us 2 root 3. All right. Last two examples here. Please pause me, and then I'll show you the answer here in a moment. Okay, for this first example, we have 3 squared plus 6 squared is going to be equal to c squared. This is c. This is your hypotenuse over here. So we would have 9 plus 36 is equal to c squared, which gives us 45 is equal to c squared. And we'll take a square root to give us c is equal to the square root of 45. Now I know there's a 9 in there, square root of 9. So that is 3 square root of 5. Did you guys get 3 square root of 5? Awesome. Good job. Okay, last example. Ooh, we've got a 13 here. All right, hopefully you tried this one. If not, please pause me again. For this example, your setup is going to be 5 squared plus x squared, this is a missing leg, is equal to 13 squared. So we get 25 plus x squared is equal to 169. And we'll go ahead and solve. I'm going to isolate my x by removing the 25 from each side, and so we get x squared is equal to 144. I'll take a square root, and 144 is perfect. So x is equal to 12. Okay, that's going to do it for this video. We just recapped the Pythagorean theorem. Very, very important and used with a lot of applications of mathematics. So don't forget this one. Make sure, do you know the Pythagorean theorem? Can you identify the hypotenuse of the right triangle? Can you use it to find the missing right side? And kind of the extension here, or might be the most difficult, is finding a simplified square root, if necessary, in those last examples. All right, I'll catch you in the next video. We're going to go ahead and do some more work with right triangle trigonometry. Like the video, subscribe, support to my my channel. I'll catch you in the next math video. See you later. Bye.